This is a lesson on long division in a unit on elementary math theory. I'm beginning with a review of addition and multiplication to get a sense of moving forward with adding things up, with multiplying things together, because division is the opposite of that. So if we understand it going forward, we can get a sense of what we're doing going backwards. Addition is taking several items and just summing them. So in this example, I have 1, 2, and 3, and I add them all together. And we can represent that with I have 1 star, I have 2 more stars, I add 3 more stars. All together, when I add them all together, I have 6 stars. Multiplication is the summation of groups of an equal number of items. For example, staying with 1, 2, 3, I have 1 group of 1, 2 of 1, and 3 of 1, and that equals 6 of 1. But it could be the case that I have 1 group of 2. Here's 1 group of 2. I could have 2 groups of 2. Here's 2 groups of 2. And then I have 3 groups of 2. Here's 3 groups of 2. 1 group of 2, 2 groups of 2, 3 groups of 2. When I add all of those together, I will have 6 groups of 2, or altogether, when I put them all together here, that's 12. And that's multiplication for me, when I add together multiples of the same number of groups. Here's an example of 1 group of 4 plus 2 groups of 4 plus 3 groups of 4. Well, that's 6 groups of 4 altogether, and that's 24. And I've exemplified this with some dots here. Here's 1 group of 4, here's 2 groups of 4, here's 3 groups of 4. Well, altogether that's 6 groups of 4, and if I went through and I counted every single one of those dots, there'd be 24 dots. Division is going backwards. We take that large group of items and we split it up evenly into groups. So 24 stars can be evenly divided into 6 groups of 4, or conversely 4 groups of 6. I can do an example here maybe a little simpler with 6 stars. When I look at 6 stars, I can divide it up into 2 groups of 3, or I could divide it up into 3 groups of 2. And that's division. I take something larger and divide it up into even groups. 24 can be divided into 3 groups of 8 or 8 groups of 3. 24 can also be divided into 12 groups of 2 or 2 groups of 12. So there's multiple ways that I can divide up 24 into even groups. I wanted to cover the notation for division because as we move towards long division, there's a different type of notation. The standard notation for division is the division sign with the 2 dots and a line in between. So 24 divided by 2 is 12. We can also represent division with a fraction. Here's 24 over 2, which can also be written this way, 24 over 2. When I take 24 and divide by 2, that equals 12. The house is a little bit different. When we move towards long division, we have to create a house. And the number that is getting divided into smaller groups goes under the house. And the number that is the size of the group we want is outside the house. So this would be 24 divided by 2. 24 is underneath the house. It's getting divided by 2, which is outside the house. And the result goes above whatever's in the house. So the answer is 12. So 24 divided by 2 is 12. I wanted to talk a little bit more about how to do long division. Long division allows a complicated division problem to be broken up into smaller division problems. So when I think about 24 divided by 2, there's 2 columns here. There's a column for the tens, and there's a column for the singles. And what we're doing is we're dividing up the problem into a division of the first column, here the tens, and then another repetition of that, a division of the ones column. So when I think about 24 divided by 2, I already know the answer, it's 12. But what we do to begin with is we take 2 and we ask how many times does 2 go into whatever number is out front. And here it's the tens column. So when I think about how many times 2 goes into 2, well, 2 divided by 2 is 1. 2 goes into 2 1 time. So what do I do with that? In long division, what we need to do is figure out what's next. What's the next step in order to divide? So what we're going to do, what you do is you take whatever number you put on top and multiply by the number out front that you're dividing by, and you put that under here, 2, and subtract. Okay? So what it's saying is that 20, remember we're in the tens column, 20 can be divided up into 10 groups of 2. That's what this is saying. This is the tens place. So I bring the 2 down and it evenly divides and I have nothing left over. Because 2 divided evenly into 2, there's nothing left over. The next step is to bring down the 4 and I'm left with just 4 sitting here. And I'm going to erase the 0 so it's not distracting you. We're not going to really use it, but it's the result from the last step. So I bring down the 4 and now the question will be, how many times does 2 go into 4? Okay, now we're in the ones column. We're trying to figure out how many times this 2 goes into the 1 column. Well, you know the answer. 2 times 2 is 4, so I will put a 2 up here. And notice I'm getting 12, which is what I expected. My next step is to take the 2 that I just wrote on top, multiply by 2, and then write the answer down here. So 2 times 2 is 4, and when I divide, I get an answer of 0. And I know that 12 groups of 2 or 2 groups of 12 make up 24, and it's even. I'm going to repeat this process for this next problem. I'm going to put 86 under the house, and I'm going to put 2 out front. My first step is to ask, how many times does 2 go into 8? Well, 2 goes into 8 4 times. I'm going to multiply 4 times 2 and put that down here, 8, and subtract. I get 0, which I expected. 2 goes evenly into 8 4 times, so I have nothing left over here. My next step is to bring down 6. And just like over here, I'm going to repeat the process. How many times does 2 go into 6? 2 goes into 6 3 times. Again, I'm going to multiply whatever I just wrote down, the 3, multiply by what's out front. 3 times 2 is 6. I'm going to put that down here. And I can see that 2 goes evenly into 86 43 times. Or conversely, 43 goes into 86 2 times. So 43 times 2 equals 86. This final example is a little bit different. We're going to approach it the same way. We're going to put the first number under the house and the second number outside. And we'll ask ourselves, how many times does 2 go into 7? Well, 2 goes into 7 3 times, but not evenly, right? There's 1 left over. I can take 3 sets of 2, that adds up to 6, and then there's 1 left over. But all I need to know is that 2 goes into 7 3 times and no more than 3 times. So I'll write 3 here. I multiply 3 times 2 and I get 6 down here, which I expected, and we're going to subtract these. And because 6 does not go evenly into 7, because 2 does not go evenly into 7, when I subtract these, I have a number left over. On the first 2 examples, I had no number left over, so I made it a little bit easier. But here I have a number left over. I leave that number there, and then I bring down the next one from the ones column. And that's the same thing I did over here. I bring the number down from the ones column. And now I ask myself, how many times does 2 go into 12? 2 goes into 12 6 times evenly. So I can write 6 up here. And so when I multiply 6 times 2, and I write that down at the bottom and subtract, I have nothing left over. And I know that 72 is an even number and it should divide evenly by 2. And I know that now 36 times 2 equals 72. Let's do a little bit more difficult long division problems, longer division problems. And I have hundreds here rather than just tens. I'm going to take the first number, put it under the house, and have the other number outside. I ask myself, how many times does 2 go evenly into 1 and no more than that? And the answer is it doesn't. 2 doesn't go evenly into 1. So what I will do is put a 0 here. It's kind of a placeholder. And I'm going to move over to the next number. So I'm going to say, how many times does 2 go into 12? Now I'm considering both the hundreds number and the tens number. How many times does 2 go into 12? Well, 2 goes into 12 6 times evenly. So I'm going to take 6 times 2 and multiply and get 12. And I have nothing left over. And I expected that. 2 goes into 12 evenly 6 times. I bring down the 4. And this is similar to the previous slide that I put together. How many times does 2 go evenly into 4? 2 times. 2 times 2 is 4, and I write this down here. And so I know that 124 divided by 2 is 62. Or 62 times 2 equals 124. Again, what I did was I asked myself, how many times does the number out front go into the first number? It didn't in this case. So I move over to the next number. How many times does 2 go into 12? That's how I got 6. I went through and subtracted, brought the 4 down. 2 goes into 4 2 times. Bring the 4 down. I get 0. Let's do the next one. It says 186 divided by 2. Well, I know 186 is an even number, and so it should evenly divide by 2. How many times does 2 go into 1? It doesn't. So I'm going to move over and consider the first 2 numbers. How many times does 2 go into 18? Well, 2 goes into 18. It takes 9 2's in order to make 18, or 2 9's. I multiply 9 times 2. I get 18, and I subtract that, and I have nothing left over. Bring the 6 down. I ask myself, how many times does 2 go into 6? 2 goes into 6 3 times. 3 times 2 is 6, and I have nothing left over. And I expected that, nothing left over. I know this is an even number, so that 93 goes into 86 2 times. If I take 2 times 93, 93 times 2, I get 186. Let's do the last one here. I made it a little bit different. 172 divided by 2. Does 2 go into 1? No. So I have to consider the first 2 numbers. How many times does 2 go evenly into 17? Well, 2 goes evenly into 16 with 1 left over. So what I'm going to do is put an 8 here, right? 8 times 2 makes 16, so I can write 16 down here, and I'm subtracting. I know that there's 1 left over when I do that. I subtract, and I'll bring down the 2. So now I have 12 down here. Now I'm going to ask myself, how many times does 2 go into 12? 2 goes into 12 evenly 6 times. 6 times 2 is 12, and I see that there's nothing left over. And I expected that. Nothing left over because 2 is an even divisor, divides evenly into 172. 86 times 2 equals 172. So that's some basic long division. I haven't introduced all of the components of it because all of these numbers have divided evenly. Notice that all of these have 0 remainders. This is what we call a remainder. There's nothing left over. Nothing left over. These divide evenly. But sometimes they don't divide evenly. We saw that in this problem here. The Quotient-Remainder Theorem gives us a way to think about division in terms of multiplication and addition. Any number can be divided by any other number with a remainder left. So if I take some number, it can be divided into a number times another number plus some remainder. And I put an example down here. If I take 27 and divide by 6, well, we were looking at 24 divided by 6 earlier, right? 24 divided by 6. Well, there's 4 groups of 6 in 24, and that divides evenly. So I might say that 24 equals 6 times 4 plus nothing, no remainder. There's nothing there that I need to add on in order to get to 24. 24 is 6 times 4. As opposed to example I had on the previous slide, 17 equals 2 times 8. Well, that brings me only to 16, and I need to have some sort of extra on there in order to make up the difference. And this is what we call the quotient-remainder theorem. I can take any number and divide it by the divisor. That will give me a quotient and a remainder. So in this situation with 27, 27 can be divided into 24 plus 3. And I know 24 is 6 times 4. And I still have this remainder 3 that I need to add on in order to get total to 27, right? 24 plus 3 equals 27. So what long division is going to do is give us a remainder. We won't always have a remainder of 0. Sometimes we will have some non-zero remainder. Let me show you how that works. Now I have 25 divided by 2. 25 divided by 2. We're going to do the same thing we did on the previous examples. How many times does 2 go into 2? 2 goes into 2 one time. I multiply 1 times 2, put that here and subtract, and I have nothing left over. Bring down the 5. I ask, how many times can I put 2 into 5? Well, evenly, 2 goes into 5 twice. That makes 4, right? So I'm going to put a 2 here. 2 times 2 is 4, and I have 1 left over. And that is my remainder. The quotient is 12, and the remainder is 1. So I can write 25 like this. 25 equals 12 times 2 plus 1. 1 is the remainder, 2 is the divisor, 12 is the quotient. We're going to do the same thing with this problem here. 87 under the house and do a 2. How many times does 2 go into 8? 2 goes into 8 4 times. 4 times 2 is 8, and there is no remainder. Bring the 7 down. I ask myself, how many times does 2 go into 7? 2 goes into 7 evenly only 3 times. 3 times 2 is 6, and I have 1 left over. So when I think about 87, 87 will be 43 times 2 plus 1. Let's do 75. I ask myself, how many times does 2 go evenly into 7? I just did that problem, right? 2 goes evenly into 7 only 3 times, and no more than 3. 3 times 2 is 6. I subtract and have a 1 left over. Bring down the 5. How many times does 2 go evenly into 15? 2 goes evenly into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1, and that's my remainder. So I can say that 75 equals 37 times 2 plus 1. Each one of these numbers can be divided by a number and have some quotient and remainder. That's the quotient-remainder theorem. I picked some harder problems here to practice with. 124 divided by 3. Let's do 124 divided by 3. How many times does 3 go into 1? It doesn't, so I have to consider the first two numbers. How many times does 3 go into 12? 3 goes into 12 evenly 4 times. 4 times 3 is 12. I subtract and I have no remainder. Bring down the 4. Now I will ask, how many times does 3 go into 4? 3 goes into 4 evenly just one time. 1 times 3 is 3. Subtract, I have a remainder of 1. So I can say that 124 divided by 3 can look like this. 124 equals 41 groups of 3 plus an additional 1 on the side. 186 divided by 4. I ask myself, how many times does 4 go into 1? It doesn't, so I'll consider the two numbers. How many times does 4 go evenly into 18? 4 goes evenly into 16. 4 times 4 is 16, so I'll go 4 times 4 is 16, and I have a remainder of 2. 18 minus 16 is 2. Bring the 6 down. Always bring that next number down when you subtract. I ask myself, how many times does 4 go into 26? 4 goes evenly into 24 6 times. So I will write a 6 up here. 6 times 4 is 24. And I will have a remainder of 2. 172 divided by 5. Okay, I know this will not be even. I know there will be a remainder because this doesn't end in a 0 or a 5, so there has to be some remainder. I bet the remainder is 2 because it's 2 more than 170, which I bet divides evenly by 5. So I ask myself, how many times does 5 go into 1? It doesn't. How many times does 5 go into 17? 5 goes evenly into 15, which is less than 17, which is 3. 3 times 5 is 15. I subtract and get a 2 left over. I'll bring down my next 2. And now I'll ask myself, how many times does 5 go evenly into 22? Well, 5 goes evenly into 20 4 times. 4 times 5 is 20. I subtract and I have a remainder of 2. So that's the remainder. I can say that 172 equals 34 times 5 plus an additional 2. And that is how long division works.